We can start. So Jatan, like you can start presenting your screen and start with the first question of bi-weekly
Uh,
yesterday's contest. Hello, am I audible?
yeah. I'm sharing
Sure,
the
sure,
screen.
sure.
Is it visible? Please
Yep,
confirm.
it's visible. So we go by like this. First, we talk about the problem statement. We just briefly explain what the problem statement says. Then we just give a brief of the approach we are trying to implement, and then the time complexity and space complexity analysis. That's it.
Okay. So should I start?
Yep, sure.
So like from my understanding, so we are given a nums array, and in the nums array, we should check if the elements in the nums array are divisible by 3 or not. If the elements are not divisible by 3, we do operation of adding 1 or subtracting 1, and then we check again if it's possible to be divisible by 3 or not. If yes, then we increase the count and then we return the count. From my approach, so like I took the length for the traversal and then count integer, and like I'm traversing to the nums array and like checking if the number is divisible by 3 or not. If it's not divisible by 3, so like I am having a temp1 and temp2, one for adding and for subtracting. So like initializing with the same element numsi and numsa, and for adding we add 1, and for subtracting we subtract -1. Like then again we check if the addition is subtractable divisible by 3 or not. If yes, then count plus plus, or if divisible by sub, then count plus plus and return the count. Yeah, that's my approach.
Got it. So you were telling that you will either subtract one or add one.
Yeah,
So anyone has any problems in this? Like why uh, we are either subtracting on one or adding one?
actually it's given in the question itself, so right.
No, but we can
Yeah.
also like we can make multiple subtractions on a single digit as well, or a number as well, right? So let's say the number is 5. Okay.
Mhm.
So if we subtract 1 2 times, it's divisible by 3, right?
Yes.
So so the main key observation that you have to make here is that
Mhm.
every number can be converted into a multiple of 3 using only one operation or zero operations. Okay. So
Yeah.
is this observation clear or I need to explain more?
No, this is clear.
Like everyone, so that we can move forward. Like you can just give a thumbs up. That's it. Like Ritik, Siddharth, Saumadeep, Dawn, Nitesh.
Yeah, it's clear.
Yep. So so yeah. So we can move. So basically, like we are either adding one or subtracting one. So if we need to use either one of them, we are increasing the count, and that's it. So we can move to the next question. So anyone, like I would encourage a different person who has solved the next question to come up. Like maybe Somadeep or like Siddharth. Like I think Siddharth has solved. He told that he has solved 3 questions.
Yeah. So I'll present my screen. One
Yep, yep.
second. I hope my screen is visible.
Yes, yes, it's visible.
Okay. So in this question, what was given that we are given a binary array, and like for example, this is our binary array, and you can do the following operations on array any number of times. Choose any 3 consecutive element from the array and flip all of them. Okay, and then return minimum operation required to make all elements equal to 1. This is okay. So in this question, what I did was I started from the first index, and I tried to like make this, because for the first index now we don't have any other dependency. So if it is 0, we have to make this one. Otherwise, we can't make this one by any other way. So
Correct.
if this is 0, I made it 1, and further like for the next 2 element, that also like I flipped that like this. So I did it. So I did it. 1 second, Anis.
Sure.
Let me grab some water actually. Yeah.
Sure, sure, sure.
Yeah, like continue with the other question? Like, can someone like start
Okay,
continue with
like
this
anyone
question?
else, Ritik?
Yeah.
Ritik, I think how much? I think you solved 3 or 2. Jatan, I think you solved 2, right? Yesterday. You can
Yeah.
continue with the second then. Siddharth will
Yep.
continue
Yep.
with the third.
Okay. I'm sharing my screen. Is it
Sure,
visible?
sure.
Is it visible now?
Yes, it's visible. So the problem
Okay.
statement he has already told. You can start with the
Approach. Yep. Yeah.
algorithm.
Yeah. So like here again, taking the n as a nums length and the count. So like I will be traversing to the nums, and like as the example stated, so like we flip the zeros to one to make all the elements in the array one. So like we need to return the minimum number of operations. So what I did is for a number for zero, like I flipped to one.
Just a
Here,
moment, Jatan. Before going into this,
Yeah.
so what the first observation that Siddharth and Jatan both told, that to make the first element 0, or let's say if the first element is 0, to make it 1, we have to flip the first 3 elements. So why we are doing this? This is clear, right? Like this is the only way to flip the first element if it is 0, that we have to flip the first 3, right? This is
So we
clear,
have
right?
to only pick one element at a time.
No, the question says that uh, if you choose a index, you have to choose 3 consecutive index. So if you choose 0, you will also have to choose 1 and 2 along with it, right? So let's say if the first index has 0, so the only option to choose 3 consecutive elements which includes index 0 is 0, 1 and 2, right?
Got it.
Make sense? So if the first element is 0, we will have to flip the first 3 elements no matter what.
Mm-hmm.
This is clear, right? Bujishish?
Bujes.
Cool. So for every element, let's say for the first element, if it is 0, we will flip 0, 1 and 2. Similarly, after flipping or let's say after making the first index as 1, we move to the second index. Okay. Now if the second index is 0, what will be our option? To flip second, third and fourth, right?
Yeah.
This is clear, right? Because
Clear.
we can't flip 1, 2 and 3, because 1 we have already made 1. So if we flip 1 again, it will become 0 again. Okay. So we can't
Okay.
flip index 1, 2 and 3 in to make or to let's say convert the second index to 1, right? Because we have already made the indexes before 2 equal to 1, right?
Got it.
So if we have to perform operations, we have to use indexes after 2 or from 2.
Okay,
Okay.
got it.
So the simple algorithm
So that.
is if the ith index is 0, we will flip I plus 1, I plus 2.
अच्छा. Simple था थोड़ा.
Simple thing. Now after
हाँ.
this, we will check that if all the if all the array contains 1, we will return the answer, otherwise we will return -1. Okay.
Okay.
Now
So
let's say after when -1 arises, if the last two elements are 0, if any of the last two elements are 0, because if any of the two last element is 0, we can't flip that back to 1, right? Because
okay.
we don't have numbers after that, and we will have to always choose 3 elements.
हाँ.
Make sense?
हाँ. Sorry.
Nitesh, Ritik, Soumyadeep, Don.
Yes, Anish. Yes.
Yes.
Cool. I think that's the algorithm. Jatan has already explained. Ritik has given a like. Nitesh, you didn't speak for a while.
I'm getting it done.
Cool. So we can start with the third one. Siddharth, are you ready?
Yeah, I am ready. I
We
will
can start with the
this.
third.
One sec.
Sure.
Okay. Okay, so in the third question, the only difference from the previous question was, so let's say this is our array. So in the previous question, if we have to change this 0 to 1, we have to take all of these three elements and then flip all of them. But in this question, what was given that if we have, if we select any index I, and we have to change the whole array from this I to the end. So one observation I made in this question was I started from the back. So for the one we don't have to do anything, but if when we like encounter the first zero, we have to make this one. Now how can we make this one? So if we think clearly, so if we flip all of these elements, like these three elements, then this will become our one, but these two will again become zero. So what I did was I I counted the number of continuous zeros which were present in the array. So for all of the zeros, what I can do is I can take here and I can flip all of these elements. And again, I can flip these two elements so that these two will become again one, and these three also will become one in that process. So I counted number of the continuous zero sequences, and that would be the answer. But again, suppose if we have zero at the last at the end, so in this case, we only have to flip this once because there is no any leading one in front of this. So so for this case, like if dumps back is zero, I just subtracted one from the answer, and then I return the answer.
Anyone has any doubts? Like you, he was like a bit messy, but he actually told the correct thing.
Yes, was a clear
Just present the solution once more, Siddharth.
Yeah.
So like what did you not understand? I will explain from the beginning once more.
Yes, yes.
Cool. Tell me if my screen is visible. It's visible, right?
Yes.
So the question
Yes.
says that there is a array. Just a moment for some. Yeah, just a moment. Yeah. So the question says that if you have an array, so if you flip this index, you will also have to flip the index after that, right? This is clear or not? Like,
Correct.
Yes.
Clear. Yes.
so
Yeah.
let's say if I flip this index, so how the indexes next to that will be affected?
Correct.
How the indexes next to that will be affected? Like, let's say if I flip this indexes, so they will be like flipped, or I can say they will be added by 1, right? If they are 1, they will become 2, which is 0 basically. Like they will become like x plus 1 mod 2, okay? All the indexes after this. So if we flip the ith index, all the index after I will be added by 1 modular by mod 2. This is clear,
Yeah.
right? Hello.
Clear.
Yes, essentially, we can hear you.
So this is understandable, right? What I'm trying to tell you. So let's say uh, I am trying to calculate the value of this jth index. Okay. So how the jth index will look like if, let's say, I have made an operation on ith index, and let's say I have made an operation on the uh, yth index. Okay, so let's say I have made the flip operation on y and I. So how the jth index will look like after these two operations? Will it remain the same or will it be flipped?
It will be same, right?
Yep, it will be the same. This is understandable, right? Because if we flip 2 times, it will be the same.
Correct. Yeah.
So uh, when we are at the jth index, or when we are at any index, to know that what is the current value of that index, we will have to keep a count of the operations we have made till now. Okay, so the count of the operation in this case is 2. So if the count is even, so it will be equal to the original value. If the count is odd, it will be flipped. Okay,
Correct.
this is understandable, right?
Yes.
So now after knowing this value, let's say so after knowing the current value, if the current value is 1, we will add 1 to the answer, and we will also increment the count by 1, because we have to make this index 0. And if it is 0, we do nothing, we move on to the next index. This is the algorithm.
Oh, super.
Everyone got it? Kaushik, Dawn, Ritik,
Yes.
Jatan. Jatan, I think you didn't solve this. So did you got it, Soumyadeep?
Yeah, I got
Yeah.
it.
So this is basically like the main observation here is that this one, like if before reaching the jth index, if I have, let's say, k number of operations, so how will it affect the jth index value? So if you made this observation that if k is even, it will remain the same, if k is odd, it will be flipped, the rest of the things are very easy. So this was the main observation. Cool. I think we can move to the next question then. So anyone wants to volunteer for the next question? I don't. Anyone has solved or upsolved? This is actually a tough question. Okay, so let's read the question first. So it says that you are given a permutation. Okay, so you are given permutation from 0 to n minus 1. So it will have 0, 1, 2 till n minus 1. Okay. And you are given some requirements. Okay. So the requirement says that you have to count the number of permutations such that it follows all the requirements given in the requirements array. Now, requirements array, every index in the requirements array has two integers. The first integer is end and the second integer is count. So it says that the number of permutations you have to calculate the number of permutations which follows the following conditions, that for every requirement it will follow this, that permutation 0 to end will have exactly count inversions. Okay, now for people who don't know what inversion is, it's like, let's say if I take an example, 0, 2, 1 and 3. So 2 comes before 1 in spite of being 2 larger than 1. So this is an inversion. Okay, so you understand, everyone is okay what knowing what inversion is. So if a larger number comes before a smaller number, it's called an inversion. Looks good.
तो 1 2 3 नहीं होगा, फिर 2 1 3 या फिर 3 1 2 ऐसे ही होना पड़ेगा उसको.
That's a not, means I am not talking about that, I am trying to explain what an inversion is.
हाँ वही बोल रहा हूँ.
So let's say, how do you calculate the number of inversions? So the number of pairs where a larger number comes before a smaller number is the number of inversions. For example, in this array the number of inversion is 1, like where 2 comes before 1. Okay, now if I take the example of, like, let's say 3 2 1 and 0. Okay, so the number of inversions here is like 3 comes before 2, 3 comes before 1, 3 comes before 0. So 3, now 2 comes before 1, 2 comes before 0. So 2 more inversions. Now 1 comes before 0. So 1 more inversion. So total 6 inversions are there in this array. Okay. Clear?
Oh, got it.
So they say that you need to find the permutation or the number of permutations where, let's say, it will follow every requirement. Now every requirement has a end index and a count. Okay, so let's say if I take this sub array, so let's say the end value is 2. Okay, let's say the end index is 2, so I will take 0 1 and 2, right? 0 1 and 2, the sub array 0 1 and 2. So the inversion count from 0 to 2 should be equal to count. Okay, so the permutations must follow these requirements. So the question is clear, right? The question is clear to everyone, right? Okay. So now let's see the how can we think of a solution. Okay. So let's say I want to use DP. Okay. So now let's say so those who haven't started DP, by the way, so I have given the video for transition states and like how to think of states. I have uploaded 2 videos in the DP module. You can see those. So it will help you to think that how you should think about the transitions and DP states while solving a DP problem. Okay. So let's say I want to take the DP state DP I and J, which denotes that I have considered I elements and till now there are J inversions. Okay. So let's say I have considered the elements from 0 to I, and from 0 to I there are J inversions in the array. Okay. This is the state I want to describe. Now how the transitions will be? Can anyone think of the transition? How can we make the DP transition? Anyone? Wild guess. So let's see it, let's visualize it, how we can make the transitions. So let's say you have already constructed a permutation from 0 1 from index 0 1 2 till the I minus 1th index. Okay, right? So you have already constructed this permutation, and let's say this subarray has k inversions. Okay, so now in how many places can you put the ith element? In how many places you can put the ith element? Come on, like this is easy. How many places are there to insert the ith
I
element?
places.
I places, right? So we can insert at the beginning, we can insert between 1 and 0, we can insert between 1 and 2, we can insert at the end. So there are total I places. Okay, so think of this, if we place at the end, so how many inversions will the new permutation have, or the new list will have, if we insert at the end?
It will be 0.
But initially we already have k inversions, right, in this array.
Yeah, k plus like 0. There will be 0 additional inversions.
So it will be so one state can be dp I minus 1 k, right, where we insert at the end, right? Now let's say if we insert before I minus 1, how many inversions will be added with k? Sorry, this will be not k, this will be j, since we are taking this state as j. Okay, so yeah, coming back to the original question. So if we insert before I minus 1 I, so how many added inversion will be there along with j, or let's say k?
There will be 1.
1. So dp I comma j can also come from dp I minus 1 j minus 1, right? Now let's say if I insert before I minus 2, so there will be 2 more inversions, so it can come from I minus 1 j minus 2 also, right? Everyone is getting what I'm trying to say?
Makes sense.
Others, like Siddharth says, makes sense. Others? Kaushik, Nitesh, Don, Ritik. This you are
Give me
getting
the
the
idea,
how the transition is coming. This you are like understanding, right?
Transition, yeah, Anish, but that relation, that DP relation, I'm not getting.
So what I'm trying to say is that, like, let's say if the permutation from 0 to I minus 1th index already has j inversions, okay, so if I add, so let's say there are dp I minus 1 j permutations, which means that there are, let's say, these many permutations with the numbers from 0th to I minus 1th index and j inversions, right? This you have understood. Like, Don, you can just tell me what you are not really understanding.
Um,
So I will just explain it once again. So let's say I have made the permutations using 0 to I minus 1 as index. Okay. So these many indexes I have used and made permutations. Okay. So out of which, let's say, uh, x permutations has inversions j. Okay.
okay.
So if I insert ith index at the end, so what will be the inversion count? It will be still j, right?
Correct.
So I can add this x to the number of to dpij because it counts the number of permutations with j inversion and considering the first I elements, right? So I should add x to it, x to this number, right? You are understanding why I am trying to add x?
No.
Okay, so let's take an example. So let's say that there are three permutations which has j inversions and are formed using the first two elements. Okay,
Okay.
so I now need to count the number of permutations using the first three elements and has three inversions. Okay,
Okay.
so if I take these let's say if I take these three permutations and add the third element at the end, so those permutations becomes three element permutations with inversion 3. So let's say we take permutation a has two elements, okay, and has inversion count 3, okay, or let's say has inversion count, let's say 1, okay. So if I add another element at the end, so it will become a 3 element permutation and it will still have the same inversion count, right? This you have understood, right?
काउंट तो वो पहले वाला ही होगा ना.
हाँ, inversion count same रहेगा, number of elements
Same ही
will be
रहेगा.
so the inversion count will remain the same, the number of elements is increasing by 1, right? If I insert at the end, so this is the same thing, the inversion count is remaining as j, the number of elements is becoming from I minus 1 to I.
अच्छा अच्छा, लूप के साथ वो i का वैल्यू धीरे धीरे कम होता रहेगा पर j का वैल्यू कांस्टेंट ही रहेगा, सेम रहेगा.
No, this is just a transition state. I am talking about from how we can calculate dp I and j. We are not talking about for loops here. First understand the transition.
हाँ हाँ, वो समझ आ गया कि उसका वैल्यू कांस्टेंट रहेगा, ये चेंज होगा.
Don, like, is it clear, right? If, let's take an example. Okay, so let's say that there are two permutations. One is 0. Let's say the permutations are 1 comma 0 and the second permutation is 2 comma 0. Okay, so in both the cases the number of inversion is 1, right?
Correct.
Now let's say, so let's say this is denoted by dp of 2 and 1, right? So dp of 2 and 1 contains these two permutations or denotes these two permutations and has a value of 2, right? Like these two permutations. This is clear, Don?
Yes.
So now let's say I want to add a third element and let's say the third element is 3. Okay. So if I add 3 at the end, so now the inversion count still remains 1, right?
Same.
So if I have to calculate the value of dp 3 1, so I need to add this value of dp2 and 1 to this, right? Because I need to add these two permutations to my combination of 3 and 1, right? Because what I am doing with 3, I am actually taking the permutations or the permutations in the state 2 comma 1 and just appending 3 at the end.
Okay.
So I need to add these permutations to this 3 comma 1 state.
Okay. There is no changes in the that second column, like in the inversion. That's why it remains same.
Yep, there is no change because I am adding at the end.
Okay, got it.
Now let's say if I don't add it at the end, instead I add between 1 and 0. Okay,
Huh.
so the inversion count will go up by 1, right?
Yes.
So it will be now looking like 1 3 0 and 2 3 0. Okay, so now the inversion count is 2, right?
Yes. Huh, correct.
So we will now be adding dp2 comma 1 to dp3 comma 2 as well, because we can put 3 in the middle as well. Okay, so we will be adding this 2 value to dp3 comma 2 as well. So that's the relation I was trying to make. So
Okay.
if you see 3 and 1 comes from 2 and 1 and 3 comma 2 comes from 2 and 1 as well. So
Okay.
so one state is I minus 1 j, where the inversion doesn't change. Now the second state can be like I minus 1 j minus 1 as well. Like if I put the ith element at the second last place, so the inversion is getting incremented by 1, right? So j minus 1 will be incremented by 1 and will become j.
Okay.
Like,
Okay, got it.
so similarly I can put at the second last place and get it incremented by 2. Okay,
Okay.
so like this it will be like till I minus 1 comma j minus I. Okay, now j minus I is the case where we put the last element in the beginning. So let's say if I put 3 in the beginning, so 3 comma 1 comma 0, or if we take a generic example it will be better. Okay, so let's say in this problem if we put the last element in the beginning, how many inversions are we increasing? Think, like if we put the ith element in the beginning, how many inversions are we increasing?
It's really I.
It is yep, it is getting increased by I, right? Because the ith element will be greater than 0th element, it will be greater than the first element, it will be greater than the second element, it will be greater than all I indexes. So basically, sorry, it will be so if we put the element in the first place, so it will be, the inversions count will be getting incremented by I. Okay, so it will go all the way from I minus 1 j to I minus 1 comma j minus j minus I. Okay, so I think that this might not be understandable right now, but the basic idea or the basic dp implementation is this, that dp I minus j will represent the number of the number of permutations with I elements and j inversions. Okay, and I think Siddharth has already got the algorithm, I feel. So
Yeah, actually, I was not able to deduce like the transition states.
yep,
Uh,
so
I was very close, but not able to deduce.
so
completely.
there is one more catch in this. Okay, so you will not add all of these to the dp I minus j since there is a requirement constraint. Okay, so you will add only those states out of these which has a requirement constraint. Okay, like if j minus 2, if there is a requirement of j minus 2 in I minus 1, then only you will add this state. I am telling this for Siddharth, not for others. Like, don't try to indulge in this. Like, you will go back and try to solve it. Okay, so I'm trying to basically solve for the second part of this question. So Siddharth, like there will be one more catch here. So since there is a requirement clause, so let's say if the index I minus 1 is in requirement, so you have to make sure that j minus 2 is also in the requirement, that there is a pair I minus 1 comma j minus 2, then only you add this dp state. Otherwise, if I minus 1 is there in the requirements, you don't add this state. Okay. So if I show you my thing, means my code, so if the ith element is in the requirement, I have to also make sure that k is also there, or what you call j minus 1 in the dashboard of the drawing here.
Okay.
So if I minus 1, there is a requirement with index I minus 1, you have to make sure that there is a requirement with I minus 1 index and j minus 2 count, then only you add this. Otherwise you don't add this, because that will not satisfy the requirement. Okay. So people, like, this is, I told you this is hard. Okay, like it only has a problem like solve count of 18%. So it's okay if you don't understand it right now. So I think you have got a basic idea, right? So after this, like, you can always go back. I have already given the code in the Discord server. You can refer to the code, see discussions, see hints, and like you can always ping the doubts in the Discord server after you have like means solved it, or see, means saw the things on your own. Like take time, see things, put the doubts in the Discord for this problem. Okay, it's not something that you will get in the first go. It's a hard problem, admit that, and like make peace for the time being. Okay, but everyone has got a basic idea of what the dp state and the transitions will look like, right? Don, you have understood the
Yes, yes, I
transitions,
did.
right?
Yes, yes.
So go back and look at into it. If you have doubts, you
Yeah,
can always put that in the Discord server. Okay.
sure, sure.
So ideally, like maybe like for the beginners, like you should ideally target the first three, and like Siddharth, who are already in the advanced or intermediate, like all four. And like once you are in the intermediate or advanced, you will understand the fourth one as well. Like Siddharth understood most of the algorithm. Okay. So we can go to the weekly contest discussions. So I think somebody dropped off. Okay, cool. Anyway, so who has solved the first one? Like, I think Kaushik should volunteer. He has solved one, I guess.
हाँ भैया किया क्या ओ एक सेकंड क्वेश्चन थोड़ा सा ओपन कर दो So uh, here we have to find out the minimum average of the smallest and the largest element. So basically क्या किया एक array में जितना value था उसको
Kaushik,
sum
in
किया.
English, please. Kaushik, in English, please.
Okay, okay. So what we have to do is that we have to find out the average of the smallest and the largest element. So what I did is uh, just did a sum of all the elements in the array and just divide by the numbers of elements in this array. Uh, I think that's the correct algorithm. Yeah,
Yep.
is it correct?
Yep, it's correct. Like, I am, see, when I'm training you to volunteer, like, as I told, that explain the code or the approach so that everyone understood. Okay.
Okay. First of all, I did is just take the size of this vector, and if there is no value, just return 0. Yeah. Then I took a double value, matlab just take a variable sum, and then add all the elements over here by adding into the sum variable, and then just did a average value, like uh, divide the sum by the number of elements and got the average and just return it.
Cool. I think everyone has got it. Like that's the algorithm. Simple. Take the sort the array, take out the first and last element every time, and take the minimum of those averages.
Uh,
Yes.
Cool. I think we can go to the second one. Like the second one is on uh, minimum. No, minimum area to cover all the rectangles. Anyone who done this? This is very
Yeah.
simple actually.
Hey,
Some
Anish, I would like to present
great,
this.
great.
Yeah, so my screen is visible.
Yep.
Yeah, so basically this question will give us a 2D binary array consisting of 0 and 1s, and we have to find the area of the rectangle that will contains all the 1 in the 2D array. So basically my approach was ki I will find the minimum most leftmost one and the most rightmost one, both in the row order, and for the column I will find the most top and bottom index, and then basically just return the difference between the maximum and minimum, considering zero based indexing, and return the area length into that. So yeah.
Yep, that's very simple. Like if you have to cover all the ones, you take the minimum row, you take the minimum column, you take the maximum column,
Correct.
you take the maximum row, take that area of rectangle. So you have four endpoints of the rectangle if you have the minimum of all four, of all two basically. Basically the top left and the bottom right corner values with the maximum
Correct.
and
All the
minimum. Yeah, and
boundaries.
then you can take the one. So let's go to
Yeah.
the third. And like if anyone is having any problem, like don't hesitate. Like it's very, I would say, tiring to ask everyone that if you have any problems. Okay, so if you have problems, just stop people right away in the middle and ask your doubts. That will be much more smooth. Okay, so let's go to the third one. Anyone did the third one? Siddharth?
Yeah, I would like to take this
Cool, cool.
once. Okay, so in this question, we have to maximize the total cost of alternating subarrays. So I will try to explain this with an example. Suppose we have an array like this. One second. One, two, three, 1, 2, 5, 4. So we have to divide this array into certain partitions. Suppose I put one partition here, so this will become one subarray. I put second partition here, so this will become our second subarray, and this will become our third subarray. So in this way, there is no any limit. You have to partition into case subarray or something like that. We can partition into any subarrays we want. So like I have done three here. So what this person is asking, after partitioning, you have to we have to calculate cost of each subarray and then add the total overall cost of each subarray, and that overall cost should be maximum. So the cost is defined like this. So suppose we have 1, 2, 3, 1. The cost of this will be 1 minus 2 plus 3 minus 1. So it will be alternating plus and minus. So in this case, it will be 1 minus 2, that is minus 1, plus 3, that is 2, and minus 1, that is 1. So in this case, cost will be 1. So is this clear? Like how we are calculating the cost of the array?
I would like to add one more very simple observation before going into
Yeah.
it. So having a subarray of length 3 is equivalent to having a subarray of length 1. And having a subarray of length 4 is equivalent to having a subarray of length 2. So basically, what I'm trying to say here is that like having one subarray of length 3 is equivalent to having 3 subarrays of length 1. It will have the same value at the end. Okay. And having one subarray of length 4 is equivalent to having 2 subarrays of length 2.
Okay.
This is clear? Like everyone got this observation, or I will show some examples to like
Yeah, can you explain the question first? Like I didn't get the question.
Siddharth,
whole
explain
question.
the question once more.
Okay, yeah. So, like, I will not read the problem statement. I will like try to explain it from my end only.
Sure.
So,
Sure.
suppose there it is our array 1 2 3 1 1 2. So, in this problem, what is being asked is we have to divide this array into certain sub-arrays. So, like, if we divide this by here and then by here, so we have divided it to three parts: 1 2 3 1 1 2. Like
Okay.
in this question here, if you see, it has divided into 1 minus 2 3, and other one was just 4.
Okay.
Like this was one, other one was this. This was the optimal division for this array. So we have to divide it in that way, and after dividing this, we have to calculate the cost of each subarray. So there will be cost associated with this subarray, then there will be this, then there will be cost associated with this subarray. And then we have to add the cost of each subarray, and we have to maximize that overall cost.
Okay.
Is this clear?
Yeah, it's clear now.
So now
Okay.
coming
And
back to
how
me,
we are
before
and
that,
how we are
just go ahead.
calculating the cost is like simple. We will take the first, then alternating plus minus. So like 1 minus 2 plus 3. Suppose here if there was 5 and 3, then it will be 1 minus 2 plus 3 minus 5 plus 3. I hope this is clear.
Yeah, it's clear now.
So the basic observation what I told is that 3 subarrays of length 1 is equivalent to 1 subarray of length 3, and 2 subarrays of length 4, sorry, 2 subarrays of length 2 is equivalent to 1 subarray of length 4. They will actually yield the same final result. Is this visible, understandable to everyone or not, or I will explain more?
Understandable from my guys.
Everyone, because this is the building block or the building observation for this question. If you understand this is basically a house robber problem. Jatan has understood. Dawn, Somadip, Kaushik, Ritik, Nitesh. Dawn, you got it right?
The cost calculation method I got, the thing
So
you mentioned.
let's say like I take a subarray of length 3. Okay, so
Okay.
let's say A, B and C are there. A, B and C are there. Okay, so according to the cost calculation, what should be the value of this subarray? A plus B plus C, right?
Yeah, but alternative numbers will be negative.
No. It says that my screen is visible first of all, right?
No, not yet.
Okay, so it says that every number will be the middle one will be yes, so the middle one will be negative, yes. So it will be A minus B plus C, right?
Correct.
Now let's say if I want to make it two subarrays, A comma B in one subarray and C, okay, so it will also have the same result, A minus B, and this, since this is a new subarray, it will also have C, right?
Yes.
So what do you understand from here? So there is no point in having subarrays of length 3 or more than 3, because we can always break those subarrays into smaller subarrays. So simply if we have a subarray of A, B and C, we can simply break into A and B and C like this. Okay, because it will have the same answer. So there is no point in having subarrays of length greater than 2. Okay, so the observation is we will have subarrays of length 1, we will have subarrays of length 2. So now the DP becomes very easy. So if I define DPI as the value, if I consider the first I elements, so we will have only two states. If we have a subarray of 1, so we will add the value of DPI minus 1, which denotes that we will have a single element subarray with element I, means we will have a subarray with element only I, and there is a second case that we will have I and I minus 1 together. So we will add DPI minus 2. I minus 2, and we will add the value of the subarrays along with it. So if we take I minus 1, So the subarray will only contain the ith value. So we will add the value of nums I, and the second case is that we have I and I minus 1 in the subarray, okay, which is subarray of size 2. So I and I minus 1. So for length 2, what we do is that it will be nums I minus 1 minus nums I, okay, and the answer will be simply dp of n, where we have considered all the elements, okay. So this is a simple dp transition state. So the first one is that we take a subarray of 1. So the subarray contains only this element, and basically we make a new subarray and we put ith element into that. So it will, the final value will be the value of the I minus 1th elements, basically the value we have made considering the I minus 1 elements, plus nums minus I, which is the value of the new subarray, or the value which we have got considering I minus 2 elements, and the value of the subarray containing I and I minus 1th element, which is nums I minus 1 minus nums I, okay. And then we return the last element in the dp, which we get considering all the elements. Simple, clear?
Yeah, I got the idea, Anish. I need to try to solve this.
Cool. Anyone did the fourth one of this, of today's weekly? Fourth one is basically bit of casework, and it's extended version of the second question. Anyone did this, or like should I start? Okay, I will start. So what did we see in the second question? So we saw that if we need to cover all the ones, before that I will read the question. So in the second question, they told that you will have to make one rectangle to cover all the ones. Okay. Here they are telling that you have to make 3 rectangles to cover all the ones, and the sum of the 3 rectangles should be minimum. Okay. Clear? Everyone? Kaushik, Siddharth, Jatan, Ritik.
Yes.
Ritesh. Okay.
Yes.
Cool. So basically, let's say if this big rectangle covers all the ones, okay, we need to break this rectangle into 3 parts, ideally. Okay. So let's say out of the rectangle or the grid we are given, this big rectangle covers all the parts. So we basically need to break these 3 rectangles into break this rectangle into 3 parts. Okay. This is clear till here? So how can we break this big rectangle? One can be simply like this, that they are vertically adjacent. One can be they are horizontally adjacent. Okay. Like what I mean is that, like for this case we can simply make a partition like this. Okay. For the horizontal thing we can make a partition like this. Okay. The third case can be like we make a partition like this, that we first make a horizontal partition and then make a vertical partition. Okay, this can be also a choice. So the third choice is one horizontal, two vertical, side by side. Okay. The it can be also the reverse as well, like the horizontal is at the top and like it is at the bottom. What I mean to say is that it's like this. Okay. Similarly, like there can be one vertical, two horizontal, like this, and the reverse of this as well. Okay. So what I'm trying to say is like this. Okay, so these are the 6 possible cases of dividing a big rectangle into 3 pieces. Okay, this everyone has understood?
Yeah.
So basically it's very simple. By as we did in the second problem, calculating the max row, max column, minimum row and minimum column, we get the top left and bottom right. So we know these 4 points, right? By calculating the minimum and maximum thing. So the minimum, so this point is minimum row, minimum column. This point is uh, maximum row, minimum column. This point is maximum row, sorry, uh, ma- minimum row, maximum column, and this point is maximum row, maximum column. Okay, fine. Hello everyone. Cool.
Got it. Good.
So now let's say for this division, we will have to introduce a few more variables. So let's say if I, so we all, for every partition we know these 4 points, like we know this one, we know this one, we know this one, and we already know this one in this partition. So we will have to know these 4 points, like this one, this point, this point and this point. So we have to figure out these 4 points, or we have to figure out these 4 points which will give us the optimal result. Okay, and for these 4 points we also know some of the things. So if I consider this point, okay, so we already know the row of it because the row of it will be similar to this. So for this point we need to determine the column. Similarly for this point we just need to determine the column. Okay, so we have 2 variables here because if we determine the column of these 2 points, these 2 points will also automatically be detected because we already know the row from these 2 points, and if we know the column of these 2 points, we will also know the column of the bottom 2 points as well. Okay, so for this partition we have to take 2 variables, let's say column 1 and column 2, iterate from the minimum column to the maximum column, and find out which pair of columns gives us the most optimal result. Fine, so we are done with the first case. Likes everyone, like if you have understood, or doubts if you don't. Kaushik has understood, Siddharth, Jatan, Don, Somadeep, Siddharth has given a like. Okay, so similarly for this one it will be similar to columns, just the columns will be replaced by rows. Okay, so now let's take a hybrid example like this one. So we know the corner points already, so we know this, we know this, we know this, we know this. So we need to figure out this point, this point, this point and this point. So in this point we need to figure out the column, which column is identical or optimal, and in these 2 points, this one and this one, okay, in these 2 points we need to figure out the row. Okay, because we already know the column. So we will iterate the row from maximum row to minimum row, and we will iterate the column of these points from the maximum column to the minimum column, and tell us which one is giving us the optimal result. Okay, so like this we will first figure out that for which case we need to find what, whether it's the row, whether it's the column, and then iterate over the range from minimum to maximum column and simply brute force to find out which one is giving us the optimal answer. Okay, for all the 6 cases, and out of all the 6 cases which one gives us the best answer, we will take that. It's clear, right? It's brute force question, but you have to figure out those 6 cases. That's the observation for this question.
Anis, can you explain the example number 1 of this question from the problem? Like
Okay.
from the website, from the problem itself. Example 1, yeah. Like how we achieved this thing from your, like from what you said, ki we will divide. We will try to find with the help of those 6 cases.
Okay, so basically, like the main box is so the main box is like the whole one, right? So
Hmm.
there are, I would say, six. First one will be what do we have? Like 0 0. Aha. This is 0 2. One more thing I actually forgot, like you have to apply inner optimizations on the L rectangles as well. I will come to that, don't worry. So
I guess that is 0 3.
okay, no, we are starting with 0th index, right?
Yeah, 0 1 2 3. Okay.
1 2 3. No, these are like one columns. Okay,
Okay, okay, got it.
so this one is 1 0. What happened to my drawing pad? And this one is 1 2, right? Okay, so basically, like one more thing you have to do is that, like after you have figured out which will be the optimal column and the row, so for every three rectangles you will also have to make a inner optimization as well. Means basically do this part again, like for every rectangle find out the minimum and maximum row and minimum and maximum column which covers all the ones for that particular rectangle. Okay, I will explain with this example. Actually, Siddharth asked this doubt, and so it will be easier to explain with this doubt. So it will be solved with the first case. Okay, Siddharth, so we are directly considering the
Yeah.
first case. Okay, so we already know that the row for this will be 0, right? We need to figure out the column, as I told. Similarly, the row for this will be 0, we need to figure out the column. This one, it will be 1, we need to figure out the column. So if we figure out the column of the top two, the bottom two will always be, means it will be the same. Okay,
Right.
so we iterate. So basically there are two variables, column 1 and column 2. So we can simply run a for loop. Maybe column 1 ranges from 0 to 2, or let's say it ranges from 1 to 1. Okay, because it can't be 0, it can't be coinciding, because rectangle 1 has to at least have one column. Okay, so it starts from minimum column plus 1, which is 1 in this case, and it iterates till maximum column minus 1, which is also 1 in this case. Sorry, just a moment. You were right, this would be 3 and this is 2. Okay, this is 3 and this is 2. Yeah, so minimum column will iterate from 1 to 2, it will be between this range, and column 2 will be iterated from range c1 plus 1 till the maximum column. Okay, this is understandable, Siddharth?
Yeah.
Okay, so basically you will run this for loop and you will find that column 1 will be 1 and column 2 will be 2 by iterating over the for loop and using brute force. Okay, so if I write this will be minimum column plus 1, minimum plus 1, and basically it will be greater than minimum and less than maximum. Okay, this one. So you get 1 here and you get 2 here. Okay, so now you know your endpoint. So it will be 1, it will be 2, it will be 1, it will be 2. Okay, so now your majority question is how do we get this off, right? Right, cool. So basically, as I told, after you have done with this, so now you have three individual rectangles. First one is from 0 0 0 to 0 1, 2 0 to 2 1, right? Second one is from 0 1 to 0 2 and 2 1 to 2 2. Third one is uh, 0 2 to 0 3 and 2 2 to 2 3. right?
Yeah.
Siddharth, right? So now apply or perform the second question operation on the individual rectangles again. So consider only this rectangle and find the smallest rectangle that will cover all the ones.
Hmm.
Okay.
Understood.
Then again perform the individual operation on these rectangles and find out which one will give. So if you perform on the second rectangle, you will find the maximum and the minimum column, that thing you perform that operation again, it will automatically give you that minimum and maximum row both is, so the it will give that the minimum row is 1 and the maximum row is 2. Okay.
Like, so we have to find the bounding box, the tightest box which which ignores all the zeros on the boundary and only contains one.
Yep.
So that will be second. Okay, got it.
So basically first you have to find that which division gives you the most optimal answer, or like basically you have to try all of those. So first you have to consider all 6 cases and find out the divisions, and then perform the operation again on the individual rectangles, so that you can reduce the individual rectangles again to the most optimal rectangle. So the first case in this has given a certain answer, right? So like this is the whole operation for the first case, which is this. So you have to perform similar operations for the other 5 as well. Okay.
But Anis, how did you came up with this idea? Like we can divide the rectangle into like these three, like these six different
If you
types.
see that there is no other way actually, like I tried to draw all 6, means all the possible. So what came to my mind, like I saw that beyond this there is no other way to divide this.
Okay.
Okay, so the you can tell this is intuition. Also you can tell that to divide into 3, first you have to divide into 2, right? Okay, so you can, what I did was that, like first I divided the rectangle into 2. Okay, so now
Yes.
I have to divide one rectangle into 2 again, right? So let's say I want to divide this rectangle again into 2, so there is only one way. I divide it like this, or I divide it
Actually,
like this. Okay,
yeah, understood. Very
so
similar.
this was the intuition to come up that only these 6 cases are possible. Okay,
Understood.
and
Yeah.
for every case you have to run this algorithm which I just explained for the first case, and after this which one is the most optimal, you take that. Got it? Like the basic idea is clear to everyone, right? How we are like using or using the brute force for all the 6 algorithms or 6 divisions and taking the optimal of them. Cool, I think that's all. I think I have already provided all the codes in the Discord server. You can go through them, you can always absolve them when you have time, and actually you have to absolve them if you want to increase your ratings. And you all know the target, you have to reach 2000 plus rating on LeetCode. So okay, so go back, absolve them. If you have doubts, refer to my solutions. If you still have doubts, put the doubts in the Discord server. Okay, so I think that's it. I think
Yeah.
people who are showing up are really consistent and continue this basically. So we will again come back in the next week with the discussions. Till then, goodbye and happy solving. Bye everyone.
Bye.
Yeah. Bye,
Thank you.
everyone.
Thank you, everyone.